আচ্ছা, বিসমিল্লাহির রহমানির রহিম। সো তোমাদেরকে আজকে হোমওয়ার্ক দিয়েছিলাম মোশন 1 থেকে 16 পর্যন্ত যে ক্রিয়েটিভ আছে সেগুলো। এর মধ্যে তোমরা আমাকে ডাউট বলছো 11 ডি 12 ডি আর হচ্ছে 13 এর সি। ওকে, তো 11 ডি টা ফার্স্ট আমি ডিসকাস করতেছি। 11 ডি তে দেখা যাচ্ছে দুটো ফিগার দেয়া আছে স্টেনে, তাই না? এবং ডি তে বলছে from figure 1 and figure 2 give comparative discussion of motion in different parts। তো প্রত্যেকটাতে দেখা যাচ্ছে দুটো করে পার্ট আছে। একটা পার্ট হচ্ছে ও এ আর একটা এবি পার্ট, আবার এখানে ও এ এবি পার্ট। তো দুইটা গ্রাফ দুটোটা কিন্তু সেম না, একটা হচ্ছে ডিসটেন্স ভার্সেস টাইম গ্রাফ আর একটা হচ্ছে ভেলোসিটি ভার্সেস টাইম গ্রাফ। তো এইখানে ডিফারেন্সটা কোথায়, মানে মোশনে ডিফারেন্সটা কোথায় হবে সেটা আমরা দেখব। তো ক্লিয়ারলি দেখা যাচ্ছে ও এ পার্ট ইন ডিসটেন্স ভার্সেস টাইম গ্রাফ is time graph. Okay, we know that in distance versus time graph, whenever it is an upward straight line, in distance versus time graph, when it is an upward straight line, we can say that the velocity is constant. Okay, the velocity is constant. That is why in equal amount of time, equal amount of distance is being covered. Okay, so the velocity is constant. We can say about the motion of the body. The body is in constant velocity. Okay, and it continues up to 10 seconds. First or for first 10 seconds. That's one of them, for first 10 seconds. Okay, and within this 10 seconds, the body covers 20 meter of distance. See, from 0, it covers 20 meter of distance. The distance covered in OA part is 20 meter. Sorry, meter, 20 meter. The distance covered is 20 meter. So this is an OA. Now in AB part, as you can see, the time is going, but the distance is not increasing nor decreasing. Now this happens when the body is stationary. The body is stopped. It is not going forward. Okay. If the body is going forward, then the distance will increase, right? But the distance is not increasing. That means the body is stopped at some certain point. So in AB part, the body remains stationary. The body remains stationary for next 10 seconds. That is in AB part, okay? From 10 to 20 seconds. For next 10 seconds, you can write, or you can write from 10 to 20 seconds. Okay? And the velocity is 0. So, the velocity is 0. Also, the distance is 0. Distance covered is 0. Is 0. Why? Because the body's velocity is 0, so it's not going forward. As a result, it is not covering any distance. Achha. One more thing actually we could have done here, that I just remember, we could have calculated the velocity here. Okay, what is the velocity? We know that v is equal to distance by time. Velocity is equal to distance by time. So what is the distance covered? 20. And what is the time taken? 10. So 2 meter per second. Okay. So in this part, kindly calculate the velocity also. It's better if I can tell what is the velocity. I am saying that here if it is maintaining a constant velocity, better if I could tell you the value. So here, as they have written the time and the distance, so it's better if you can tell the velocity also. So show it in this part. And here the velocity and distance covered is 0, so no question. Now we will take a look at figure 2. Okay. Now it will be velocity versus time graph. In velocity versus time graph, in bracket you can write that it is figure 2. In the first one you can write the figure 1. Okay. So in figure 2 OA part, what we can see, with the time increasing, the velocity is also increasing. So when there is increase of velocity, the velocity is not constant. The velocity is not uniform. Or here we could have written the body is in uniform velocity for this, but here the body is not in uniform or constant velocity. Rather, the velocity is increasing. When there is increase of velocity, there is what we can say. There is acceleration. Very good. Okay, so there is acceleration, and we can calculate the value of acceleration from here. I will show you. The body is in non-uniform velocity. Non-uniform velocity. Okay, the velocity is increasing. In this part, so acceleration, there will be acceleration, right? And we can calculate the acceleration. Acceleration from a is equal to v minus u divided by t. So v is the final velocity. For this part, what is the final velocity? 30. And for this part, what is the initial velocity? That is 0. What is the time taken? 10 seconds. So 30 divided by 10 actually gives us 3 meter per second square. Acceleration is unit is 3 meter per second square. So we can say that here it is having non-uniform velocity, and whenever there is non-uniform velocity, there is acceleration, and the value of acceleration we can calculate and tell. Okay. What we can say about AP part? Can anybody tell me?
Sir, what is the question?
What we can say about AP part? For OA part, we could say that the velocity is increasing. For AP part, what we can say?
It is constant.
It is constant. The velocity is not changing. The velocity is uniform, right? The velocity is neither changing nor decreasing. It is constant. So in AB, the body is moving with uniform velocity. Uniform velocity. Okay. From 10 seconds to 20 seconds. Okay. And for this part, the acceleration. So acceleration will be 0. Whenever the body is moving with uniform velocity, the acceleration is 0, right? 0 meter per second square. Because velocity is not changing. Acceleration is the rate of change of velocity. If the velocity is not changing, then there is no rate of change. So acceleration will be 0. But we can calculate the distance covered for uniform velocity. Whenever I say uniform velocity, I told you to use this equation S equal to Vt. So I can calculate what will be the distance covered. S will be equal to V. What is the value of velocity here? 30. So 30 into, for how long? For 10 seconds it took place. So 300 meter. Okay. So we can say the distance covered in this AB part is 300 meter. Is it okay? You can also calculate the distance covered for this part also. It's better. As it is for 4 mark, it's better to show as much as information you can. Okay. So how can you calculate the velocity here? If you see, whenever there is acceleration, we will apply this formula as equal to ut plus half at square. Not this one. This is for uniform velocity, but this is non-uniform velocity. So here we will apply this formula. So if I apply this formula, s equal to u, initial velocity for OA part, right? we are calculating the distance or applying this formula for OA part. What is the initial velocity? 0. So it will be 0 into what is the time for this part? 10 seconds. 0 into 10 plus half AP squared. Acceleration A, we already calculated here, that is 3 into T square. T is 10 seconds. So 10 square. So 0 into 10, it will become 0 plus half into 10 square means 100. 100 into 3 is 300. 300 divided by 2 is 150 meter. So in this OA part, it will cover a distance of 150 meter, and in the next 10 seconds, it will cover a distance of 300 meter. So these are the information you can say about this two graph. Okay, give as much information as possible. Okay, so do you have any doubt? You need to read the graph. Okay, I told you in the class whenever I was teaching this in the school, I told you that the graph will talk to you if you can read the graph. Okay,
Sir,
follow.
sir, in exam also we have to draw the graph.
Obviously, you have to actually not this graph on the graph paper, because this is already given here. Okay, already given in the question. So if you just draw it on your answer paper with pencil and pencil, that is okay. But let us say, take a look at question number 9. In question number 9, you can see that a table is given, right? Question number 9 and also question number 7. If a table is given and then you are asked to draw the graph, then you have to do it on a graph paper, not in a normal page on your white answer sheet. Okay, you have to draw it on a graph paper. Acha, so done. 11D. Can I move to 12D? Okay. Acha, one more thing I wanted to tell you. If you are free today evening after Maghrib, okay, please do join the class of grade 10, because today I'm going to discuss a very important topic of grade 10, okay, that is the effect of magnet on a current carrying wire, and also the working principle of DC motor and AC generator. Okay, I will discuss about this couple of topics, and I think it's better if you also attend, okay, because after some time you will also have to study this. Huh?
কয়টা বাজে?
7:10, inshallah. Try to attend the class if you are not busy. So let us take a look at 12D. From motion, actually, the graph related problems are much important, okay, more important than the other type of question. So here we can see a graph again is given. It is a velocity versus time graph. Velocity versus time graph is the most important graph. The graph looks like this, right? 0, this is velocity, meter per second. This is time in second. There is a point A. Is x. That means we do not know the time. At this point, the velocity is 50 meter per second. Then at point B, is 3 point, and the velocity at this point is 30. So again at C, 30 seconds, and the velocity is just same as A, okay? This and this just along the same line. Maybe our technical for any but you can understand. This is point C, and this is point D. This is 40 seconds, and this one is at 50 seconds. Okay? Achha. In 12D, na? Achha, how to change this coming in acceleration when the car directly comes B point to E point. Acha. Okay. Now here we can see that from B to E, this whole part is divided into three parts: BC, CD, DE. Correct or not? So in BC there is an deceleration as the velocity is going down. We can see that from O to B the velocity is increasing. Then there is a decrease in velocity. Then it is uniform velocity for some times, and then again the velocity is decreasing. Now, when there is velocity increase, we say that acceleration is taking place, and when the velocity is decreasing, we say deceleration or retardation is taking place. Okay, so three part. What is asked in the question that what if the line comes from B to E directly? Okay, B to E directly, not divided in three parts. It will come from B to E directly. Then what will be the change in acceleration? So we will see that. Okay, we will see. Now, at first, we need to calculate the deceleration for this three part. Okay, at first, we will say that currently, according to this graph, this is the deceleration. Then again, we will calculate if the line had come from B to E directly, then we will calculate the deceleration, and then we will compare the deceleration that we get. Okay, so at first, let us calculate the deceleration for BC part. So 12G for BC. Acceleration is equal to v minus u divided by t. Final velocity. In BC, final velocity is at c, which is 15. So 15 minus b, it is the initial point, so 30. You understand, right? B is the initial point, c is the final point. So final velocity we will take from point C, and initial velocity we will take from point B. Divided by time. What is the time difference? 20 to 30, it is 10 seconds. So minus 15 divided by 10 is equal to minus 1.5 meter per second square. This is the acceleration for BC part. Okay. Later, let us represent by A BC so that I can say this is acceleration for BC part. Okay, which is minus 1.5. Can you tell me what will be the acceleration for CD part? Can anybody tell me?
0.
0. Very good. Because there is no change of velocity, so there will be no acceleration. No increase, no decrease. No change of velocity. So we can say the acceleration will be 0 meter per second. Very good. And for DE part, again we will calculate using the same equation, final velocity. In DE part, E is the final point, so the final velocity is 0. Minus the initial velocity at this point is 15, and the time difference is 10. Here also I can see the deceleration is minus 1.5 meter per second square. Okay, so I have calculated the acceleration for the current situation. Okay, then I will show that if the line had directly come from B to E, then what would be the deceleration? Okay. So I will write if now before you write this, you need to actually redraw the graph again. Okay, how you need to redraw? Means this you have to draw once, then again before writing this, and again you have to draw the graph the way I am showing now. B to D directly join. Okay, B to E directly join. Okay, so now acceleration of BE we will calculate. B minus U divided by T. The final velocity is at P, which is 0. minus initial velocity is here 30 divided by the time t, 20 starting from 20 ended at 50, so 30, right? 10, 20, 30. Yes. So minus will be there. 30 divided by 30 will give us 1 meter per second square. So we can see that if the line directly comes from B to E, the acceleration is not going to remain same. Okay, it is not going to remain same. It was 1.5 minus 1.50 and minus 1.5 in the previous, in the three parts, right? But here we can see the acceleration would be minus 1 meter per second square, which is not the similar with the previous case, right? So this is what you have to say. They asked how, what actually question টা একটু ভুল আছে, ওকে? এখানে বলা উচিত ছিল যে what change will occur in acceleration when the car directly come from B to E. What, এখানে একটু গ্রামাটিক্যাল মিস্টেক আছে। যাই হোক, আমরা যেহেতু বুঝে নিচ্ছি, আমরা আমাদের মতো করে আনসার করে দেব। So this is 12B. Can I move to 13C?
Yes, sir.
Okay. Okay.
Okay.
So let's see 13C. So 13C, there is a stem. As I go through the stem, I will list up the given information. 13C says that the car starts from rest. Whenever they say start from rest, the initial velocity is 0 meter per second. With constant acceleration, A is equal to 2 meter per second square. For 6 seconds, time is 6 seconds. After that, it moves with constant speed for 1 minute. Okay. So then it moves. There is 2 times. So let us consider this is t1 and another time there is t2, which is 1 minute. I can write it equal to 60 seconds. Acha. For this type of problem, I like to draw a diagram in which I show the necessary or the given information. Okay, how the diagram is drawn? This is first 6 seconds, okay, and this is the next 60 seconds. For first 6 seconds, what I know, the initial velocity here 0. This is I know. Okay, the acceleration for this part I know. Acceleration is 2 meter per second square. Okay, and no other information I know, right? Here only I know that I can apply this equation here for this 60 seconds, because in this part they maintain a constant velocity or a uniform velocity. Okay, so let us see, calculate the distance traveled with constant acceleration. Okay, they have told us about constant acceleration, so we will be considering only this part. That is not needed for now. So the distance covered with constant acceleration. Whenever there is acceleration, okay, we will apply this formula, x equal to ut plus half a t square. I think this was very easy because u is 0, given time is 6 plus half a is 2 and t square means time 6 seconds square. Now this was rather a easier one. 2 কাটাকাটি 6 square মানে 36 মিটার। এটাই তো आंसর।
আমার কাছে হার্ড লাগছিল একটু।
আচ্ছা, যাই হোক, অসুবিধা নাই। তো এই জিনিসটা মনে রাখতে হবে, যখনই অ্যাক্সেলারেশন থাকবে তখন এই ফর্মুলা অ্যাপ্লাই করব, আর যখন অ্যাক্সেলারেশন থাকবে না বলবে যে মানে ইউনিফর্ম ভেলোসিটি, তখন এই ইকুয়েশন অ্যাপ্লাই করব। এই দুটো জিনিস মাথায় রাখলে অনেক ইজি হয়ে যাবে বিষয়টা। ওকে, আচ্ছা, তো তাইলে মোশনে তোমাদের আর কোনো ডাউট নেই বলতেছো, বাট সাদিয়া তুমি এখনো আমাকে বলো নাই। সাদিয়া, তোমার কোনো ডাউট আছে?
না।
ওকে, গুড। তো তাহলে পরের দিন তোমাদের হোমওয়ার্ক থাকবে এই কত 24 পর্যন্ত আছে। তো নেক্সট দিন ইনশাআল্লাহ এটা শেষ হয়ে যাবে আশা করি। ওকে, তো যারা আজকে হোমওয়ার্ক কমপ্লিট করতে পারো নাই, 16 পর্যন্ত করতে পারো নাই, তাদেরকে আমি বলবো এনি হাউ নেক্সট ক্লাসের আগে 24 পর্যন্ত শেষ করে ফেলো, তাইলে তুমি আপ টু ডেট হয়ে যাবে। ওকে, যেভাবে পারো শেষ করো। ওকে, এই টাইমগুলো যদি এভাবে একটু সিরিয়াসলি কাজে লাগাই তাহলে তাহলে দেখো পরের প্রেসার হবে না। তোমাদের চারটা
স্যার এখন কি
চ্যাপ্টার আমি
পড়াবেন?
হ্যাঁ
এখন কি পড়াবেন স্যার?
বুঝি নাই।
এখন কোন সাবজেক্ট পড়াবেন?
এখন কোনটা পড়াবো? এখন পড়াবো হায়ার ম্যাথ। ওই যে অ্যালজেব্রিক এক্সপ্রেশন যেটা পড়াচ্ছিলাম ওইটা কন্টিনিউ করব। তো এটা মিটিংটা
ওকে
শেষ
স্যার।
করে আমি আরেকটা ভিডিও দিব, তোমরা একটু সাথে সাথে জয়েন করো। ওকে
স্যার আমি বই খাতাটা একটু নিয়ে আসছি।
হ্যাঁ বুঝি নাই।
আমি বই খাতাটা একটু নিয়ে আসতেছি।
হ্যাঁ নিয়ে আসো, অসুবিধা নেই। আমি মিটিং দিচ্ছি, ওখানে জয়েন করো সবাই।
ওকে ওকে স্যার।
ওকে।